Hello students, let's work homework 1.0. Here we go. So the first question, now remember it's giving you questions just randomly, so your numbers will not be the same as mine. And if you miss one, the length of your assignment will be different from the length of my assignment. I don't plan on missing any, but we'll see how it goes. So we are supposed to solve the following rational inequality for x and then give the, I guess the interval where this inequality is valid. Okay, so here's the problem. Well, first thing that I should do is let's note the domain, right? So the domain cannot include 7, because if you put a 7 right there, it would say 7 minus 7, and that would be 0. You can't divide by 0, so the domain has got to exclude 7. Okay, I'll keep that in mind. Let me now factor this numerator. So that numerator factors, let's see, into x plus 3 and x minus 2. Now, for a rational expression to be equal to 0, it only takes its numerator to be equal to 0. So, really, I'm just wanting to know so the best way to do this, and the way we'll need to do it all semester long, is to draw a number line. Draw a number line, and we will call each of these points -3, 2, and 7. This collection will be our partition points. So on my number line, I will plot the -3 and the 2 and the 7. And then up above those plotted points, right here, here, and here, I'm going to indicate which one is doing what. So at the 7 is where it's undefined, and at the 2 and the -3 is where it's 0. And then we use test points in each interval to check the sign. The most convenient test point on this whole number line right here is going to be 0. If you took a 0 and put it in for x, here and here and here, you would have a positive number times a negative number times or divided by a negative number. So that means that inside of this interval, the sign is positive. Bet money that it just alternates across all of the other partition points. That I believe that is true on any, well, I should be careful. Is true for any polynomial. But this is not a polynomial. It is a rational expression. And I know it's the case because there's no duplicity. There's nothing happening that's like this. I would need to watch out if there was a even exponent there, but let's just go ahead and check just to be sure. Right here I can get a test point of 3. If I put a 3 in everywhere for x, then this would be positive and positive and negative. And sure enough, that matches up. If I used a number that was bigger than 7, like 10, then this would be positive and positive and positive, and that matches up. And if I used a number that was more negative than -3, like -10, then this would be negative and negative and negative, which would result in a negative. So this is my sign chart. This is my sign chart, and what I will do now is, since we needed to know where this thing was greater than or equal to 0, then that would be everywhere in here, and not including 7, on to infinity. So it would be the interval from -3 up to 2, closed interval, union together with the open interval from 7 to infinity. All right, super. So looks like it's this one. Excellent. Next question. Ah, I clicked the wrong thing. I clicked the wrong thing. Now I'm going to have to do another question. Great. So let me remind myself not to click that next button right there. I'm just going to cheat on this first one because I already did one like it. I got to scroll down and then click continue. Okay. Great. So I've done one question and my mastery is about 25%. Super. Up next, we have this other rational expression. All right, it is x squared plus 3x minus 18 over x minus 7, greater than or equal to 0. Okay, so once again, our domain does not include 7. And the factorization of that numerator would be x plus 6 and x minus 3. Okay, I draw my number line. I recognize that my partition points are the collection -6, 3, and 7. So there's -6, there's 3, and there is 7. This is where it's undefined, this is where it's 0, and this is where it is also 0. Now on the number line, 0 lives right there. So that is the one I will do first. If I put a 0 in for all of these x's, then I would have a positive number times a negative number times a negative number, or divided by a negative number, and the result is that it's positive. And you can bet that it just alternates like that. You should check. I'm going to skip checking. So I think that then this right here would be my intervals. So it should be the closed interval from -6 up to 3, union together with the open interval from 7 to infinity. And when you are on your homework, make sure you are careful not to pick the one that has the closed interval with 7. That one won't work. All right, continue. We are 50% of the way through. Solve the following rational inequality. X plus 1 over x plus 6 is less than or equal to 0. All right. Oh, well, my partition points are going to be -6 and -1. These are my partition points, so here is my number line, and there's -6. Over here is -1, and my easy test point 0 is right there. So if I put a 0 in for both of those x's, the result is that it's positive right there, and then it would just alternate. You can verify that it's going to alternate because if you picked some number way over here like -10, then clearly you have a quotient of two negative numbers. And they want to know where this is less than or equal to 0. And one thing I did not put was that it was undefined here, but it was 0 here. So then my interval would include -1, but not -6. All right. So it would be not including -6, but it would include -1. Super duper. And it looks like this might be the last question. Okay. And I mean, you can decide right away virtually that none of the ones that have brackets are going to be the right answer here, because it's a strictly greater than. Right? The only time you could be using a bracket is if you had, let's say, a greater than or equal to, or a less than or equal to. So here's our problem. My partition points are going to be 4 and 2. Then here is my number line, and there's 2 and there's 4. It's undefined here, it's 0 there. And over here at this super easy test point of 0, I'm going to get a quotient of two negatives. So it would be positive, and then it switches back and forth at each partition point. We're wanting to know where this is strictly greater than 0, so that would be these two wings on either end. So I go from -infinity up to 2, and then union it together with 4 out to infinity. And that should be it for this assignment. The assignment is complete. All right.